if things don't work out on this planet. Or if our itch to explore becomes unbearable at some point in the future. Astronomers have recently found out what kind of galactic real estate might be available to us. We'll have to develop advanced transport to land there, 20 light years away. But that's for later. The question right now, is it worth the trip? The destination is a star that you can't see with your naked eye, in the southern constellation Libra, called Gliese 581. Identified over 40 years ago by the German astronomer Wilhelm Gliese, it's a red dwarf with 31% of the Sun's mass and only 1.3% of its luminosity. Until recently, the so-called M stars, like Gliese 581, flew below the radar of planet hunters. They give off so little energy that a planet would have to orbit dangerously close just to get enough heat. Now, these unlikely realms are beginning to show some promise, as their dim light yields to precision technologies, as well as to supercomputers, honed in the battle to understand global changes on this planet, Earth. Will we now begin to detect signs of alien life? Or will these worlds and the galaxy itself turn out to be lifeless? And Earth just a beautiful, lonely aberration? To some, like astronomer and author Carl Sagan, the sheer number and diversity of stars makes it far more likely that the universe is brimming over with life. This so-called many worlds view can be traced back to ancient observers in China, India, Greece, and Egypt. The Quran, the Talmud, and many Hindu texts all imagined a universe full of living beings. In the 16th century, this view got a boost from astronomer and mathematician Nicholas Copernicus, who came to believe that Earth is not the center of the universe, but revolves around the Sun. 7 decades after Copernicus, Galileo Galilei used his newly developed telescope to show that our Sun was just one among countless other stars. By the modern era, this many worlds view held sway in scientific circles. A variety of thinkers considered what and who inhabited worlds beyond our own. From Martians desperate to get off their planet, to alien invaders intent on launching preemptive strikes against ours, or simple life forms on an evolutionary track to complexity. But other thinkers have been struck by a different view. The Greek philosophers Aristotle and Ptolemy believed that humans and the Earth are unique. With the spread of Christianity, this Ptolemaic system became widely accepted. The latest variation on this theme is what's called the rare Earth hypothesis. It holds that Earth and sophisticated life were the result of fortuitous circumstances that may not be easy to find again in our galaxy. Does the current search for planets shed light on this debate, sending it perhaps in one direction or the other? So far, our only good reference for recognizing an Earth-like planet is Earth. It does have some beneficial characteristics. It's dense, it's rocky, with a complex makeup of minerals and organic compounds. And it has lots and lots of water. It's also got a nearly circular orbit around the Sun, at a distance that allows water to flow, not too close and not too far away in the so-called habitable zone. That's defined as the range of distance from a parent star that a planet would need to maintain surface temperatures between the freezing and boiling points of water. Of course, that depends upon the size of the planet, the makeup of its atmosphere, and a host of other factors. And whether the parent star is large, medium like the Sun, or small. Some scientists also believe that we live in a galactic habitable zone. We're close enough to the galactic center to be infused with heavy elements generated by countless stellar explosions over the eons, but far enough away from the deadly gamma radiation that roars out of the center. If there is a galactic habitable zone, it's thought to lie 26,000 light-years from the core, approximately where we are, give or take about 6,000 light-years. According to one estimate, only about 5% of the stars in our galaxy fall within it. But even out here, in the galactic suburbs, there are hazards. Some researchers have linked mass extinctions in the past to the Sun's passage through one of the spiral arms, where other sources of dangerous gamma radiation lie in wait. Somehow, though, we've made it through asteroid impacts, climate changes, solar eruptions, and everything else the galaxy has thrown at us. Now we want to know, are there kindred spirits somewhere out there to share our survival stories with? This image shows the biggest single obstacle faced by planet hunters. We're looking at Earth, as photographed by the Voyager spacecraft, from a distance of 3.7 billion miles. Our mighty world occupies only about 1/10 of 1 pixel. Try seeing something this small at hundreds of thousands of times that distance. And try seeing it through the bright glare of a star. Faced with these challenges, astronomers have developed ways to see them indirectly. Since 1995, Swiss and American teams have discovered over 400 planets by looking for subtle shifts in the motion of their parent stars. Here's what they'd see if they used this technique to monitor our Sun for a period of 30 years, beginning in 1990. The Sun would wobble or dance about due to the gravitational tug of planets orbiting it. The technique for detecting this wobble is so exquisitely developed that astronomers can see movements down to a meter per second. That's human walking speed. But there's still a ways to go. Earth causes our Sun to move at less than 1/10 that speed. By analyzing the complexity of this movement, they have been able to tease out the sizes and distances of the different planets tugging on the star. Initially, they detected huge gas giants, many of which have wildly elliptical orbits that bring them in close to their stars before driving them way out. Unfortunately, the giants' gravity would eventually fling smaller, Earth-sized planets out of their solar system. An exception is the star 55 Cancri, where astronomers detected a Jupiter-sized planet with a nearly circular orbit. That's a good sign. Our Jupiter is thought to have afforded Earth some protection by scooping up destructive asteroids. Beyond occupying a desirable location in the habitable zone of its parent star, it helps if a planet has the right chemistry. Our Earth and solar system were likely born within a crowded scene, like the Trifid Nebula here, lashed by winds from hot giant stars, and blasted by a violent explosion, a supernova. Nuclear burning within the core of large stars is where most of the heavy elements, from iron and oxygen to carbon and calcium, are generated. as our Sun formed at the center of an immense dusty disk. These elements became concentrated in planets. Some of the most important elements in the search for life have now been detected because of a chance alignment of Earth and a solar system 63 light-years away that astronomers refer to as HD 189733. The Hubble and Spitzer space telescopes together caught a planet whipping around this star once every 2 Earth days. This is one sizzling planet, with surface temperatures up around 900 degrees Celsius. The planet, tagged HD 189733b, is so hot that a vapor trail follows in its wake. Starlight passing through this trail allowed scientists to detect carbon dioxide, methane gas, and water in the atmosphere of the planet. Then there's the Sun-like star HD 209458, visible with binoculars 150 light-years away. It has a planet known as a hot Jupiter. It's hot because it's close in, as near as 7 million kilometers from the star. Compare that to our planet Mercury, 46 million kilometers out from the Sun. Or the Earth, 146 million. Scientists estimate that stellar winds are blowing some 10,000 tons of material every second off the surface of this hot gas giant. How long before it gets reduced to just a shriveled core? That's just what happened to the star called Corot 7. Astronomers spotted a planet slightly larger than Earth and just about as dense. But because little Corot 7b is so close to its parent star, it's most likely covered in molten lava. If these planets are too near to their stars to harbor life, many of the others discovered so far are too far away and too large. Like the one orbiting a star the ancient Arabs called Fumalhaut, meaning the mouth of the fish. It's just 25 light-years away and was the first exoplanet to be seen directly. Using Hubble, scientists blocked out Fumalhaut's glare and found a planet orbiting about 10 times farther out than Saturn. It would take 872 Earth years to make just one orbit. The brightness of this planet suggests that it's huge and probably surrounded by a dusty disk. Astronomers are seeing hints of the diversity of worlds imagined by the ancients, but still only scant evidence of anything resembling Earth. Still, there's one class of stars that, until recently, had been overlooked. The M stars are the most numerous in our galaxy, around 76% of the total. They're often called failed stars, because not enough mass fell together as they were forming to fuel the intense nuclear fusion that burns in stars like our Sun. To be in the life zone of one of these dwarf stars, a planet would have to be very close in. Unfortunately, because these small stars spin very quickly when they're young, they're like electrical dynamos with intense magnetic fields that generate dangerous flares. If a planet manages to survive these blasts, it may have to endure another handicap. In close like this, it's likely to become gravitationally locked to its parent star, just like our moon is to Earth. With only one side ever facing the star, one side scorched, the other frozen. Is there any hope? On Earth, we know that the unevenness of solar heating, due to the day-night cycle, leads to oceanic and atmospheric circulation patterns that redistribute the heat and equalize temperatures. A computer simulation performed by NASA scientists showed that a tidally locked planet could, in fact, develop circulation patterns like this. In the computer model, a cloud cover developed on the light side, keeping temperatures down and air pressures high. The result? Winds that circulated the planet, redistributing enough heat to keep the rate of freezing down. That's one reason these M stars are on planet hunters' radars these days. Another reason is that planet hunting itself has taken a leap forward. An instrument that specializes in looking for solar wobbles has come online. HARPS, short for High Accuracy Radial Velocity Planet Searcher, has been on a planet-finding tear. At a recent conference, scientists announced 30 new planets discovered with this instrument. Among its most promising targets, Gliese 581, that inconspicuous red dwarf in Libra. 4 planets have been detected so far. Planet E is the lightest exoplanet discovered to date, just less than 2 times the mass of the Earth. But it's so close to its parent star that its orbit takes only 3.15 days. Planet B is close in too, and weighs 16 times what Earth does. Planet C, at 5 Earth masses, lies just inside the habitable zone, while Planet D, at 7 Earth masses, lies on its outside edge. To find out what direction these planets might have taken, scientists have sought to model their early evolution. Planet C, on the inside margins of the life zone, would have immediately been subjected to a withering barrage of solar radiation. Think Venus. Any water vapor in the atmosphere would have been stripped away. Gases spewed out by volcanic activity would have turned the atmosphere increasingly dense. A strong greenhouse effect would have turned Planet C into a hothouse. Planet D is different. Earthbound instruments show that its gravitational pull is surprisingly weak, meaning it's not very dense. That suggests that it might have migrated in from the outer parts of its solar system, carrying with it significant amounts of hydrogen and oxygen. It could be a water world, with an abundance of vapor in the atmosphere that would strengthen its greenhouse effect. Of course, there are still many unknowns. Is it far enough out to avoid becoming tidally locked? If it is locked, has it developed circulation patterns strong enough to keep the freezing down on the dark side and support a habitable climate? Astronomers will continue to study the planets of Gliese 581 in the years to come, as part of a rapidly expanding list of targets. The next era in planet hunting is now ramping up with the recent launch of the Kepler planet-finding spacecraft. Kepler amounts to a huge digital camera in space, pointed at a region containing more than 100,000 stars. Its designers are betting that some of those stars have planets, and that a fraction of them are tilted so that their planets pass between their stars and Kepler's camera. If so, astronomers will detect subtle dips in the brightness of these stars by as little as 1/100%. That's the signature of a planet passing in front. Another project is breaking new ground by combining data from several ground-based telescopes. Astronomers recently used them to probe a star called 61 Virginis, 28 light-years away. It's nearly identical in mass and age to the Sun. What's more, it was here that astronomers found the first Earth-like planets around a Sun-like star, at 5 and 7.5 times the mass of Earth. A simulation of the atmosphere of the larger one, picturing its flow of heat on a global scale, shows how much we can understand even at this distance. How long before a truly Earth-like planet is discovered? As astronomers' instruments get better, and their techniques more refined, it's likely that they'll uncover smaller and smaller planets. For now, though, the rare Earths hypothesis may well have the edge over many worlds. The conditions that nurture a habitable planet seem hard to come by, such as position in the life zone, a nearly circular orbit, and magnetic fields. The threats are many. Solar flares, marauding giant planets, tidal locking, and other lurking catastrophes. In fact, nature has handed us a paradox. Medium-sized stars, like our Sun, turn out to be remarkably hostile to life. They emit barrages of ultraviolet radiation and solar outbursts powerful enough to ruin a fledgling atmosphere. And yet, somehow, we manage. So, if it turns out that the Milky Way is filled with habitable worlds, it's not that the galactic real estate is so special, it's that life finds a way. Found out what kind of galactic real estate might be available to us. We'll have to develop advanced transport to land there, 20 light years away. But that's for later. The question right now, is it worth the trip? The destination is a star that you can't see with your naked eye, in the southern constellation Libra, called Gliese 581. If things don't work out on this planet, or if our itch to explore becomes unbearable at some point in the future, astronomers have recently. Now, these unlikely realms are beginning to show some promise, as their dim light yields to precision technologies, as well as to supercomputers, honed in the battle to understand global changes on this planet, Earth. Will we now begin to detect signs of alien life? Or will these worlds and the galaxy itself turn out to be lifeless? Identified over 40 years ago by the German astronomer Wilhelm Gliese, it's a red dwarf with 31% of the Sun's mass and only 1.3% of its luminosity. Until recently, the so-called M stars, like Gliese 581, flew below the radar of planet hunters. They give off so little energy that a planet would have to orbit dangerously close just to get enough heat. And Earth, just a beautiful, lonely aberration. To some, like astronomer and author Carl Sagan, the sheer number and diversity of stars makes it far more likely that the universe is brimming over with life. This so-called many worlds view can be traced back to ancient observers in China, India, Greece, and Egypt. The Quran, the Talmud, and many Hindu